my name is Martin White. I work with the ASTM International and particularly with the ASTM Centre of Excellence for Additive Manufacturing. I joined the ASTM just over 3 months ago, so I'm relatively fresh-faced, but before that my previous role was Chief Engineer for Additive Manufacturing at UK Aerospace in Bristol. So I'm a materials engineer by background, doctorate, master's, undergrad. Spent as long as I could at Swansea University. Thoroughly enjoyed myself. I was lucky to come out with a good background in materials. My sort of career path since then. I worked for Fraser Nash Consultancy for about 6 years. Kind of covered a lot of nuclear and aerospace, particularly defence and materials as well. And in the last 6-7 years, I've been fully in aerospace. I've worked for GK Aerospace, and before that, Safran Landing Systems up in Gloucester, and that's where my first experience of certifying large structures. So I talk today. So on the title itself, usually I use my wife as a sounding board to see whether she scrunches her nose or rolls her eyes, and this was an eye roller. She said, "How to go faster? Sounds like I'm going to take people on a fairground ride." So that's my aim today, is to try and entertain a little bit. I think the topic of standards is very, very important with additive. There are some gaps in the technology because obviously it's very much a developing field. And this talk is going to talk about what standards are available, how we can use them, why they are important, particularly for materials, and how the ASTM is looking to accelerate their adoption and therefore accelerate additive manufacturing. So next slide, please, Paula. So just a brief overview. So I think I've introduced myself. Good to see some familiar names joining the conversation as well. So I look forward to some interesting questions later. So I'll introduce you to who the ASTM are. I'm a materials scientist. I suspect I've used the ASTM standards for probably the best part of 20 years now, and I'll talk around the Committee for Additive, which is F42, a little bit of detail on actually some of the standards and how they're structured, and what the Centre of Excellence is and what that means for the industry and how can we support and go faster. Next slide, please. So, like I said, the ASTM, they're very much a global business now, a global organisation. Crucially, a not-for-profit, which actually allows them to be, or allows us to be, very independent. And I think across the globe, we cover everything from materials, testing. I did read a recent standard in draft on construction using hemp bricks, which is quite interesting. So genuinely looking at all different technologies. And the aim is to become one of the world's largest sources for standards. Next slide, please. So this is a brief pause. So one of the challenges with additive in particular, and also from aerospace, and like I said, my previous background with GKN, I actually was able to build a production team pretty much from a very small number up to almost 30 people. And alongside building a team in additive and producing parts that would fly, it's very important to be able to actually demonstrate that through a quality system. And when you're developing a quality system, you'll rapidly understand that there are a huge range of standards that you can draw on. And for me, the benefit of standards is they become very much the baseline of everything you can do. The intent is that instead of everybody trying to reinvent the wheel and doing things separately, the standard becomes very much the baseline by which everybody has that first few rungs on the ladder. So importantly, I just want to talk about different types of standards. And again, although I've used standards for a long time, I am still very much learning, and I will continue to learn as to what standards are appropriate. So if I pick on aerospace, for example, again, companies like Airbus, Rolls-Royce, GKN, etc., they will have their own company standards, operating procedures, which are relevant for them. Many big companies, some small companies will actually spend quite a bit of money doing their own research and development to actually give them the edge in particular areas where it may be things like powder testing or NDT, etc. So they'll have their own valuable IP and knowledge, which they'll actually use as their own standards. You can have wider working groups, which is consortium standards. The ASTM, for example, has a consortium which has some major aerospace and non-aerospace players in. The intent is to effectively use that to generate data and link to things like MPDS to understand how that data can be used for allowables. And there's industry standards. So, for example, again, in aerospace, the SAE standards, they are looking to drive industry to aerospace requirements. The government standards, which also link into kind of military standards, some of the DEF stands in the UK and equivalent around the world. And there's the voluntary consensus standards. And the reason these are important is because they are very, very broad and very, very wide, and they encompass many, many industries. So, for example, F42, which drives the ASTM committee, there's almost 1,000 members in that committee. So when you get an ASTM standard released, it genuinely has been through the works, it's been well reviewed, and it's a very, very well established and technically sound background for your work and your projects. Next slide, please, Pamela. So again, I will kind of dive through this because it can make you go a little bit cross-eyed this early in the morning before lunch. The F42 committee is effectively the driving force of the ASTM, which pulls together lots of technical applications and different areas of technology from feedstock to testing. And again, F42 is one of the oldest committees for additive, so formed in 2009. Like I said, there's almost 1,000 members, and beyond that linked to over 2,000 technical experts. Interestingly, the way the kind of the manufacturing group is structured is now looking at applications based. So there is FA7, which is looking at aerospace. There's also working on currently a nuclear organization, also medical devices, marine, agriculture, etc. Next slide, please, Pamela. Something I found a challenge whilst I was in aerospace was, as I kind of explained earlier, there are a vast range of standards you can use. And I think I use the phrase quite often of who is standardizing the standards. And this is something that used to really kind of drive some challenges into industry. So the ASTM and ISO, two very, very major standards bodies, actually got a formal agreement, which is a partner standards development organization agreement, to effectively have their standards as being one and the same. So now an ASTM standard is also accepted by ISO standards. There's a very close link there, and I think this is a really positive step. And again, from industry background and perspective, I don't want to be reviewing many, many different standards. I want to kind of have a really clear-cut indication of what I should be using in industry. So I think that's a really positive thing straight off the bat. Next slide, please. So I wanted to talk a little bit about, I'm not going to get into too much detail of standards, obviously limited time. I'm happy to field questions or have separate discussions later. But in terms of the way additive manufacturing structures the standards within ASTM, is within the blocks you can see on the screen here. And around some of the most fundamental things, such as terminology, you can find from company to company, country to country, certainly industry to industry, even powder beds. I think it's powder bed fusion, EBM, powder beds, this, that, and the other. There's lots of different interchangeable terms, and actually having a fixed terminology is a very good place to have that Rosetta Stone of translation. So I think ASTM is, again, from my experience, is most well established historically around testing. So E8 around the tensile testing and things like that. I'm sure the majority of people on this call would have actually used themselves in the past. And the way that the top level structure has been built is around kind of 3 stages. So obviously with additive, your feedstock is extremely important, and that will drive the quality. With feedstock, there comes the challenge around procurement. So what standard should you be buying, powder or also wire or other requirements. And then you also have a manufacturing requirement. So once you're now using a pick on powder and you want to recycle it and reuse it many times, how do you control the limits? Then there's the process and the equipment side, which becomes very much almost the actual manufacturing part of additive. And again, the ASTM is trying to keep this as a broad base, such that we, as much as possible, are almost technology agnostic. And then beyond that, there's the finished parts. So the things you make out of your feedstock with your process, how do you evaluate them? How do you test them? How do you do NDT, etc.? And then as you move down towards more specialized standards, we do have specific standards on particular powders and materials. So particularly in Ti64, for example, I'll give a little example of what actual standard will contain. And then beyond that, interestingly, we do the applications-based standards. Now, there's interesting viewpoints here that actually should the ASTM remain completely agnostic to industry, such that all their standards are applicable to all industries, or should there be that kind of driving down into the deeper levels? And this is where we are still kind of learning in the standards world of how that works for the likes of SAE, for example. So generally, there's pretty good collaboration and certainly the open transparency with the standards, which is very important. So those are kind of gives you the overview of the standards and the categories we kind of have. I think pretty much all the standards we have today for additive will fit into one of those blocks. Next slide, please, Pamela. Now, again, I didn't want to get this into a dry, deep dive scenario, but actually, when you think about, okay, so I kind of understand why a standard is important, because actually somebody's already done a lot of the work for me. So imagine you now have a new business or company that wants to set up a facility. You can rely on standards to kind of take some of that baseline effort out for your own work. And then in terms of what actually a standard will contain, but again, on the previous slide, it depends what area you're going to be working. But if I pick on Ti64, and again, slightly biased because I recently spent a lot of time in aerospace, this is an example of what these standards will contain. So first of all, on the right-hand side, really useful example for a standard is actually this is a really good repository of other information and things you should be considering. So those are the list of standards. Again, I'm not going to go through them, but it covers everything from testing to powder testing to NDT to mechanical testing, etc., etc. The standard is covering all metallic powder bed, and that also covers electron beam laser powder bed in this case. And again, as I said earlier, the ASTM is intending to be technology agnostic. So this isn't aimed at the EOS machines or SLM or Renishaw. This is intended that it could be used across the wider technology. Within the standards, you will find minimum tensile properties. Again, these are kind of fundamental properties for understanding the kind of the strength of the material. And by and large, the properties you find, they are comparable to forgings and wrought. And interestingly, particularly in industry, which is looking at kind of the higher classifications of materials, which are safety critical, one of the good places to start is to potentially replace cast material in the future. So these standards will support that. This particular specification or standard is intended that it can be used to both procure powder and also for the produce of material. Like I said, it's a really good link to all the other things you need to consider. So again, if you wanted to start a business or have a quality system, this will allow you to kind of really understand everything you need to consider, particularly when going for really challenging industries such as nuclear or aerospace or medical. Okay, next slide, please. So one of the challenges very much is that creating standards, particularly when they have a vast number of voluntary contributions, can be a very long process. There can be standards which are held up for minor things for a long time. I think, for example, we have some like 20 to 30 standards currently in ballot and review at the moment. They can take up to 2 years. So there's also, as mentioned earlier, quite a significant number of gaps within additive standardization. There's various documents out there. One good one which if you haven't reviewed is the America Makes Standardization Roadmap, and this covers a lot of the gaps and errors. It's kind of reviewed by some key players in the industry, and it looks at understanding where the gaps are. And some of the things that we've identified, not just beyond the standards, but also things like you need to improve education in the workforce and things like that. Next slide, please, Pamela. So, the title of the talk was How to Go Faster. So, for the ASTM, being a very well-established standards body, could quite happily just decide to, well, we'll just continue with additive as we do with every other technology. But because of the rapid acceleration and the rapid requirement for these standards, the ASTM decided to do something a little bit different and create a centre of excellence. Now, what is a centre of excellence? Well, effectively, it's a kind of, I liken it to very much to the UK catapult centres, where, again, being a not-for-profit, independent organisation that understands industry needs, understands academia, has some funding, is able to access further funding, and is able to kind of gel that all together. So the Centre of Excellence, I was the 5th member in that team. We have our global director based in the States, have a counterpart in Singapore covering Asia and Pacific region, and we now have 8 people. So in the last 3 months, we've hired 3 people. We are still looking to grow quite quickly, that we have open requisitions for jobs at the moment. And the reason for the Centre of Excellence is to kind of be that integrator between academia, industry, government requirements. We regularly speak to the FAA, EASA, for example, in aerospace, the FDA, medical, and we're also looking to kind of drive that forward. And the mission that we have is to close these gaps in standards that have been identified, and not just kind of drive them, but actually put some funding in to do some R&D. And beyond that, include training, education, personnel certification, and also proficiency in testing. Next slide, please. So again, a busy slide, which I'm happy to send out later. But the key one here is that there is a real need for globally accepted standards. Globally accepted standards from the ASTM, they have quite a bit of kudos, and people will use them. So the ASTM Centre of Excellence, founded in 2018, we now have some key strategic and founding partners. So, for example, in the States, particularly NASA, are really driving and guiding around qualification and certification for additive, and they have some real expertise there. Here in the UK, we're delighted we're partnered with the MTC, so the links with the DRAMA project and beyond are very, very key. And the intent with our partners is that actually when we put a request out for ideas for research to close the gaps, we're aiming for the higher TRL levels of technology, so that we will put a focus per area of funding in order to close the gap as quickly as possible. Next slide, please. So again, there's lots of information on our website, but this is a good example of the work that's been done so far. And this is the first 2 years. So we you can see you've identified some key gaps. And again, the topics cover everything metallic testing to post-processing to feedstock. And then in recent times, we've also looked at how we do testing of polymers, for example, with our partner NIA, based in Wichita. And the key is there that all this work is genuinely accelerating the issuing of these standards. So we are getting standards out quicker, and we are able to do research and development to close those gaps. So with the ASTM and COE in particular, we have the global team now. We operate very much with a startup mentality. We have some expertise, obviously myself being former chief engineer. We have academic backgrounds. We have people from medical. We have really good background and links into industry and academia. And of course, we've got the nice warm blanket of support from the F42 and the ASTM. Next slide, please. So around the R&D roadmap on our website, amcoe.org, there are a number of roadmaps which are strategically based There's one here as a highlight, for example, on research and development, and this talks about how we plan to close some of those gaps. There's also a very interesting section on data, so slightly outside of the scope of this topic, but obviously one of the key things we're working on in the DRAMA project in particular is how do you manage the vast amount of data that the process can generate. And once you generate all this data, what do you actually need, and how do you actually do something with it? So I've learned about things like data lakes, particularly from Katie in the DRAMA project. So my experience in the data world is increasing. We've held a series of workshops on data, so there's also a really good roadmap on our website for data management. Next slide, please. And then finally, I just want to talk just alongside the standards and what the Centre of Excellence offers. We offer a range of things from training to advisory services. And one of the key programs we offer, which has actually been very successful for the last few years, is powder testing proficiency. Now, what is powder testing proficiency? So in a very quick overview, I've got a couple of slides. Effectively, there are requirements with additive that mean you have to control your powder process, both from consistency, reliability, and understanding what are the key process parameters within testing. So there are a number of testing labs around the world. Many industrial users have their own testing labs, etc. And this is really a kind of a round-robin approach using the ASTM as the independent neutral body to allow people to gauge how their testing of powder, management of powder, benchmarks against others. So next slide, please. So this program genuinely works as a relatively straightforward round robin. We have almost 50 participants now globally from, I think we're well over 11 countries. I think we're more like 15 countries now. And effectively, the ASTM will send the participants some powder, and then we will ask the participants to then do the testing and the characterization of the powder against ASTM standards and then submit the results back to us. We then do the analysis, the statistical results, and then we'll be able to provide a benchmark that says, out of all the participants in the round robin, let's say 50 applicants, we can then provide statistical data. And the testing is relatively anonymous, but we provide you your own feedback directly, such that you understand where you sit, whether you're in the middle or you're an outlier, etc. And then if you sit within the key ranges, you will then receive a certificate that says you are compliant to the standards and you're able to drive that practice. Next slide, please. So, because the benefit of this is that you then have effectively a quality indicator to understand, are we testing in the right way? And that's very, very important. It gives you a good comparison against your peers and other labs, and actually allows you to have a certificate from the ASTM that says, well, actually my powder lab is accredited to these standards, and here's the evidence. So in terms of materials and standards, this is a kind of a practice which really gives benefit straight away. So you can show that you're compliant to the standards and you're able to control your material against those standards. So these are kind of some of the services that we offer in the ASTM. Next slide, please. So how can you get involved? How can you support? And how can we, the ASTM, actually give you information to allow you to understand what we can do? So there's probably some really key areas. Like I said, we now fund projects ourselves. So the ASTM has funding. We also join with our partners who will also contribute funding. And we regularly put out calls for projects. One has just closed in the last few weeks, but there will be another call in Q3, Q4 this year. And that is where we're looking for research projects, which will then be considered. The F42 committee will then work with us to decide which projects we should fund. And then those projects can be done not just by the ASTM partners, but also by other non-partners who aren't partners currently. As I said, the committee F42, joining F42 itself is a very inexpensive thing to do, and it gives you a really immediate link to wide industry. You get a really good understanding of what's going on in the industry, so it's well worth considering. Centre of Excellence events. Now, in the kind of the new normal, things obviously are changing. But as today is evidence, actually joining from what I call the spare bedroom of excellence is actually really quite easy to do, and kind of have these working groups and virtual collaborations. So our big flagship event was supposed to be held in Florida in November. We're currently just in the kind of final stages of, I think that will most likely be a virtual event. And that has over 300, I think nearly 350 abstracts submitted. It's a big conference. That was my first involvement with the ASTM Centre of Excellence. Attended a conference in Washington a couple of years ago, and that event was excellent. And it's a very technical event. It gets to the kind of the key issues: structural integrity, NDT, data, all those sort of good things. Those are contained. And beyond that, we also have, starting today, our safety certificate program. We have a general personnel certificate program, which is around multiple topics, again, presented by some key industry experts. And later in September, which is actually September the 11th, actually no, I think it's moved to the 14th now, we have a virtual workshop where there'll be some good talks as well. And of course, we're also ready to accept other ideas for future engagement as well. And Pamela's, I think, just give me the flag to wind up. I think my last slide is the summary. So thank you very much for your time. And just in summary, the ASTM, again, the not-for-profit independent organisation, is here to drive the closing of standards and meet standard needs to help accelerate the industry, and obviously to go faster. And the way we'll do that primarily is to close by funding R&T, driving education and training.